and Oracle Apps DBA, and I'm planning more to this Devops side, my DBA experience. So I'm here.
Hey, sorry, I just rejoined.
Okay, thank you.
Thank you. Just give me a second, okay? I'll just start
Okay,
sharing
fine.
my screen. We'll get going.
If anyone left, please leave in the chat. That's fine. Please.
Yeah,
So,
that's a good idea. Hope you can see my screen.
so my name is Sagar. Okay, I'm the trainer for this DevOps in AWS.
Oops,
So
I think we have a cross connection.
coming to my experience, like I have total 12 years of experience in this field. So I
Folks, do
started
you
my
also hear?
journey with Wipro as an intern. From there, I moved to TCS. At present, I'm working at Mastercard. Okay, so I'm the lead there. So I lead people of 10 there. So the complete journey when I started with Linux. Okay, I started with Linux in 1 year working with Linux client. From there, I got introduced to build and
Someone joined two calls parallelly. That's very interesting. Jaya, is that you? Okay, sorry about the confusion. I think the call might have been disconnected, so others are joining in. Apologies. Can you all hear me? Could someone confirm again? Hello? Okay, thank you.
works, but very, very limited companies. Very rare companies they use Windows. Okay, because there's no market. Okay. So here you'll be getting the
Hey, I'm not sure what's happening. I think some folks are connected to the other session. That's very weird. Good. Yeah, there's some, you know, technology always messes up something or the other. Let's just wait for one more minute, maybe. Sorry for the delay, and we'll get started. All right, folks. Again, I'm very sorry for all the disturbance, the disconnection, and everything. Hope we solve these problems forever before we go into our actual class. All right, hope you can hear me fine and see my screen. Please give me a thumbs up or say something in the chat. And hope you're not listening to two calls at the same time. Could someone please confirm, unmute yourself and
Yes, yes.
all's good, right? Okay. All right, a very good morning. Thank you for joining on a Saturday morning. So my name is Kiran and I'll introduce myself in a second. So welcome to the demo for Devops and Azure training session. Okay, briefly about me. My name is Kiran. You know, personally, nothing much other than, I like to bike. I have a total experience of 18 years, out of which last 10 plus years is in DevOps and site reliability engineering roles. I have worked in large enterprises. I've also worked in startups, and I'm not currently in India, so I have some international exposure as well. Uh, I've been training since 2019, I guess, but I've stopped in the in between, took some gap. I have taught many training sessions on DevOps plus AWS plus DevOps plus Azure. I have done some certifications, haven't actually renewed them, but yeah, uh, I did my AZ 305, designing Microsoft Azure infrastructure solutions. I did my Azure Administrator Associate. Then I also did my certified Kubernetes administrator uh, like 5 years ago. That's about my certifications I did, but again, they are not valid today because I haven't renewed them, because some certifications you have to renew every 2 years, some you have to do every 1 year, and they're all cost. Anyway, so coming to my core skills, I think I'm, I have decent experience and expertise in Linux. I have used a different set of DevOps tools. I haven't written everything here, but primarily, Terraform as an infrastructure as code tool was my go-to tool. I I also have good experience in continuous integration and continuous deployment with various tools from Jenkins to GitHub Actions. We'll talk about that in a while. And talking about containers, you might have heard about Docker. These days, it's very everywhere. And then Kubernetes and configuration management. I've used Ansible a bit. Um, So I've worked on AWS primarily, also Azure, Oracle Cloud. In my current organization, actually, we use all the first three clouds, including the fourth one, Cloudflare. Um, yeah, Cloudflare is not like the typical clouds, but yeah, I worked on that, and also a small cloud provider like DigitalOcean. So that's about me. And before we jump into the demo, I would like to set some ground housekeeping rules. So if you have a question, maybe that will already come up in the demo somewhere. So please feel free to write it down in the chat, and then we can take it up later, right? So here's the chat. So if you have a question and you think you might not remember towards the end of the demo, please write it down here so that I can see it at the end of the demo. All right. Or if I ever pause and ask for questions, you're free to ask, but most likely we'll handle them at the end of the demo. All right. Any other questions before we proceed? All good? All right. Thank you. Okay. So what is this course about? Let's see what is that we are going to learn in this course. All right. So we want to understand the IT architecture and the SDLC, which stands for Software Development Lifecycle, right? How do applications look like in production environment? What is the structure like, right? That's one thing, and particularly with cloud in focus, with the DevOps and agile practices. And of course, the key thing is we're going to learn some Azure core services. We'll talk about how does networking work in Azure, how does IAM work, identity and access management, how does compute work. We will look into a couple of storage services. So again, you know, just a disclaimer of sorts. Azure or any cloud provider for that matter these days is quite uh, they have a lot of services, right? So it's not possible to cover every service, but we're talking from the DevOps engineer perspective and what are the core services that you generally need to know. And there are always services that come up in your journey that you have to pick up on the go. All right. So we're going to cover the core services there. And we are going to understand what is DevOps and why do people use DevOps as a practice, right? So how is it implemented in day-to-day life in all the different kind of organizations. So of course, we use different kinds of DevOps tool sets. I will also come to that in a minute. And we are going to test and try all these on Azure infrastructure. Okay. So that's why this is DevOps plus Azure. So we understand what Azure is. We practice some of the core technologies in Azure and we combine them with the DevOps tools such as, let's say, Terraform, for instance, and how do we implement CI/CD for services on cloud, so on and so forth. Okay. And of course, we talk about automation and a lot of automation. How do we automate stuff? Because that's what, at the end of the day, a DevOps engineer or a site reliability engineer does, in fact, right? Automation. Like you talk about CI/CD, it's nothing but automation. You talk about Terraform, it's nothing but automation. Okay. So we'll talk about that throughout this course. Of course, AI has been quite the game changer of late, right? So everywhere AI has been um, in use, and there is like companies are encouraging their um, team members to always use AI for both code generation and various other tools. So we talk about it. We use a little bit of ChatGPT. We use a little bit of Copilot when we learn some of the tools, right? Again, a very bold disclaimer at the beginning of the course itself, beginning of the demo itself. We will see a lot of code, and you should not be afraid of code. DevOps is not just about understanding or by hatting about some tools. You have to implement them. That means you have to write code about it, but it's not like you're creating anything out of thin air. You're not starting from scratch. You're not developing programs here. Of course, you should not be afraid of developing code in the future as well, be it vibe coding or something you learn out of your own and try to develop it. You should have, not immediately, but as you progress in your career, you should start being friendly to the code, understand code, and understand the concepts of OOPS, for example, object-oriented programming. Um, and at least you should be able to look at the code and understand. And you should also understand things like what is the difference between, let's say, a compiled program like Java or C or and some other language like JavaScript or Python. What are the differences? So you have to have some sort of understanding wherever possible. I talk about them when we talk about the CI/CD. All right. Okay. That's at the very high level, and I will also give you a breakdown in terms of the tools we are going to learn, and also in terms of the services we are going to learn at Azure. In Azure, sorry. All right. So before we proceed, the big thing, cloud, right? So, what is cloud? Not exactly the one you see here. Anyone? What's a cloud? Like cloud computing. What is cloud computing? You can express it in your own words. Like there's no specific, what do you say, hard-coded reminder or something, a hard-coded definition or something. I'm sorry.
where we store the data.
Okay, right? Anyone else? All right, you're right. I mean, cloud is where data is stored, but it's also something else. So this is the official definition of sorts. Cloud computing is the on-demand availability of computing resources. So basically, cloud is nothing but it's a collection of data centers managed by a cloud provider. Okay, users can rent resources on a pay-as-you-use model without the upfront cost, right? So let's look at this in this way. Um, So if you have to commute to your office by cab every day, back in the day, let's say 2000s, if you have to commute in a car every day, you have to buy your own car, maintain it, you know, and pay insurance and everything. But now you could subscribe to something like Ola, Uber. There are like services, also something that will come every day, pick you up and drop you at your office, right? So there are different kinds of cab services. So there you don't buy a cab, you don't buy for the insurance, you don't, you know, um, pay for the fuel. All that you do is pay for the amount of the time you used, and then you say goodbye and go to your office. And again, while going back, you can, ask for a cab, go to your home, and don't worry about the maintenance of the car and everything. So cloud computing, in a sense, is the same thing, right? It's like whenever you want to use resources, you create them, you start using them, you pay for the amount of the time you used, and when you don't need them, you shut them down. And generally that doesn't happen in a production grade, but saying that, right? Um, so it is like whenever you want, you can request for computing resources. What do I mean by computing resources? It could be like storage, like someone has just said that. It could be your virtual machines. That means you want to run your software somewhere, right? Storing itself is not enough. You want to run your application somewhere, your web application somewhere, your backend application somewhere, your databases somewhere. So this needs some computing power. So you are literally hiring computers on rent from a cloud provider. It could be Azure, it could be AWS, it could be Oracle, Google Cloud, or whatever other cloud providers you have. Okay. So basically, it's like you're outsourcing your computing job to someone else. Back in the day, if you want to start an organization, if you want to start an application, right? Let's say something like Flipkart or even Ola, Uber, even Netflix for that matter, you need to build you needed to build a big data center, right? In the data center, you create a lot of, you buy a lot of computers and put them and put the heating and everything. All that thing used to happen back in the day. But nowadays, if someone has an idea he wants to implement, they don't have to buy any computing equipment. Like, they don't have to buy servers from HP or Dell and say, hey, I have these servers and I will plug in them. I have to hire data center guys. No, you can simply sign up for Amazon or Azure and start running your services on cloud, right? It's as if you have the option to rent the computers and use it for the amount of time you want to use. And if you want to scale up, that means you want to increase the number of servers you are using. You can just do it by a few clicks or through some code, right? So that's the primary difference between uh, on-premise. What we call as the on-premise is the old school of system where you maintain your own servers. The latest thing is called cloud computing. It's not latest anymore. It's been almost like 20 years that cloud has been there, right? And the key thing is you only pay for the amount of time you're using, just like your cab, right? So let's say you're using servers only in the daytime. In the nighttime, you shut them down. Let's say it's a production server, I mean, it's a development server. So you should only pay for the time you're using. You generally pay for the time you're using and not throughout the day, right? So Azure is Microsoft's cloud offering. So Microsoft Azure, it's commonly known as Microsoft Azure. So it's one of the leading cloud providers after AWS in market share, right? So AWS, Amazon Web Services, it began much earlier than Azure, I think in 2006, I guess. Whereas Azure began around 2010, but it also had some earlier hiccups. It actually changed in 2015 again with a new look and everything, right? But because of their enterprise hold, meaning already people have a lot of cloud services like Office 365, um, Active Directory on cloud, which is these days called as Azure Entra ID. So because of their enterprise hold, they could get a lot of new customers as well, right? So Azure's infrastructure is spread across the globe in 160 plus physical data centers in multiple regions. So as I said, right, cloud is nothing but it's very much on the ground. When you talk about cloud computing, these are nothing but data centers located in various places connected through high-speed internet cables, which you can demand on, which you can request to connect on demand. So that means they need to have physical data centers everywhere. So you might have heard about news about, okay, new data center is coming up in Hyderabad. Now Google is building a data center in Vishakhapatnam, um, in Andhra Pradesh. So there are data centers across the globe for Azure. Similarly, AWS has them, right? And Azure services are not just computing and storage, but they also offer some services like machine learning, Internet of Things, big data, and nowadays Azure AI and Azure OpenAI services, these are like really big, right? So everyone is trying to use some kind of large language model, build their own AI or use the ChatGPT's or OpenAI's existing models and create something. So that's happening as well, right? Everywhere Azure OpenAI services are used on a big time. Okay, so that's about Azure in a nutshell and cloud. Okay, so hope there are no questions. If you have any questions, please feel free to write it down. Um, Okay, so now we talked about cloud in a bit, right? Cloud is again, to put it in this short sentence, it's like you're using someone else's resources to run your service, okay? And you pay for them for the service. You could think of it as like a cab service in old terminology. So let's see what DevOps is all about. What is DevOps? So it's actually a set of software development practices that combine software development and IT operations to shorten the system's development lifecycle while delivering features, fixes, and updates frequently in alignment with business objective. So, how do I explain this? So there are these businesses, right? Let's talk about something like Flipkart, for instance. So, what is the Flipkart's business? It has to sell goods to the people, right? So, how do they do it? They do it through their platform. So, there is a business development team which works and talks to the clients, or their investors, and they say, okay, we're going to have these features in our website. Okay, maybe we'll have a new feature. For example, we want to have a feature where people can sell goods among themselves. That's not there, but just giving an example, right? Just like they want to integrate something like OLX within their application. So how do they do that, right? They talk to the development team and say, hey, we need to have this new feature, right? And when you talk about a new feature, it's not like it's coming out of nowhere suddenly, right? It has to have its own infrastructure, it has to have its own deployment lifecycle and everything. So DevOps is basically, in theory, it's kind of a set of practices. It's not like a tool set, right? But in practice, what happens is DevOps engineers uses some tools. The DevOps engineering teams use some tools like, it could be infrastructure as code tools using Terraform or CloudFormation or Azure resource management templates. Um, and they use tools like CI/CD tools. It could be Jenkins, GitHub Actions, or some other tool. And they start creating these services faster so that developers can develop, build, and ship it to the and it is available to the end users as soon as possible. So that's what DevOps is all about. It's all about bringing the ideas into an implemented solution as soon as possible, right? So idea is coming from the business side. They're saying, okay, we need a new feature where Flipkart users can sell among themselves, right? And now then the developers think about it, they write a solution, but it also has to be implemented on a server so that end users can see it. So this time from the idea to the time the end users can use it is what we call as the go-to market, right? For instance, so you have to shorten this time. You have to make it faster. Otherwise, maybe your competition is doing it faster than you. So you have to also constantly look at your application and see if there are any bugs. They have to be fixed immediately, right? Let's say Flipkart OTP is not working. Every time you try to log in, there is a second factor authentication, for instance. I don't know if Flipkart has it, but let's assume there is a second factor authentication, but sometimes it doesn't work. So that means it's not reliable. So you have to fix that bug, right? So that also has to be done very quickly before a lot of users are affected. So that's what DevOps is all about. It's all about decreasing the time from the idea comes from the business or the user side to the time it is actually implemented on your application, right? And also you have to care about the health of your application. So it should be always accessible. It should be um, I mean, again, in IT world, there are always disruptions, but you have to make sure the disruption meaning the service is not available. That is cut down to a minimum, right? So that's what a DevOps engineer generally does. Okay. We'll talk more about it when we go into the course, but that's the short gist of what DevOps actually means, right? So DevOps teams closely work with the development teams, QA teams, bring them closer, and use all the automation tools that are available at their disposal to make things to take the features faster to the end users, right? Okay, so basically in theory, you know it's actually a culture that aims to create better collaboration between development, QA, and operations. But in practice, it's also about using these automation tools to get things done faster. Okay. But again, it's definitely not a single technology or a tool. It's not like a, let's say Java programming language, or it's not like Cucumber or some testing tool. It's actually a set of practices, right? It's of course you use some tools along with that, but it's most likely it's never a single technology like your Java or you know VMware or anything like that. Okay. So when you say you're learning DevOps, that means you have to understand the entire software development lifecycle, every bit of it, I mean, every step of it. And then also you have to think about the tools that you can use to make the software development lifecycle shorter. So the aim of adopting DevOps is to build and release software quickly and maintain applications with high availability and resilience. So high availability is, let's say you log into Flipkart and it says page cannot be accessed. That is not highly available, right? So highly available means you set up some target. You will say that, my application will be available 99%, 99.5% of the times. That means you can only have, let's say, a few minutes of downtime in a month, not more than that, right? So that's high availability. And resilience is, yes, in the world of IT, in the world of software, it is a given that your systems will go down sometimes. So you should also be in a position to bring them back as soon as possible. That's resilience, right? So if there is some service not working on Flipkart, let's say search feature is not working. So that might happen because of a number of reasons, hardware failures, networking failures, or even software bugs. But you should be in a position to fix that faster. So that's what DevOps try to do: build and release software quickly, as well as you have to maintain applications with high availability and resilience. Okay, so you might also hear about the roles like site reliability engineering, cloud ops, or cloud engineer. These are like almost same. I mean, there is a difference between what a site reliability engineer does and a DevOps engineer does, but these are very similar. For instance, the SRE or site reliability engineer focuses on the production application. He focuses on availability and resilience, and performance of the application. Whereas DevOps is all about um, thinking about making development faster. Okay, but in some organizations, these are blurred. There is no specific role. Some people might call SRE, but you're also doing the DevOps engineer. Some people don't like the word DevOps itself. DevOps engineer, not the word DevOps, but the DevOps engineer. They think DevOps is not a job role. It's more like a cultural practice across the organization. And SRE are the teams that are going to, make sure this culture is practiced across the organization. But anyway, again, it varies from company to company. Some people might call themselves site reliability engineering, but they might be doing very basic stuff. So yeah, you might also see these kind of roles. Excuse me. All right. So let's talk about software development lifecycle. So how does it happen, right? So again, like I told you, first everything begins with an idea, and then you write code. And when you write the code, you also, I mean, when I say build here, I don't mean the uh, build like a Java build or something. I'm just talking about developing your code, right? Then what do you need to do? You need to add the configuration, okay, to connect it to the database or other services and so on and so forth. Then you have to create automation, continuous integration. So every time there is a new change in your software, it has to automatically be compiled together into a single package. So that's what we call as continuous integration. And then you have to take this code and deploy on your servers. See, all developers write their code mostly on their laptops, but you cannot give access to your laptop to the end users. The code has to stay in set of servers, right? Or server is nothing but a computer anyway. So so you have to take the code from the developer when they push it into their GitHub repository or GitLab repository, and take it and put it in the uh, servers after the CI is done. Okay, so that's CI/CD. Then we have, yeah, you deployed your application. Now what? You have to make sure the application is running all the time. That means you cannot sit in front of the computer and say if it's working or not, right? So you have to set up monitoring, and along with that, you have to set up alerting. So whenever something goes down, some service is not working, you have to get an alert internally, not to the end users, but internally. And then you take care of it. That's monitoring and alerting. So these are kind of, broad steps. This is again my own version of how software development lifecycle look like, but there are other steps as well. We are not talking about designing, we are not talking about planning and everything in this, but just giving you a high level view of what happens through the software development lifecycle, right? Then in all the cases, what you need to do is you have to take care of the source code. Source code is nothing but the code the developers write, the programs the developers write. Also, not just that, it's also about the automation workflows or the Terraform templates that you write. These are also part of your source code. So you also have to take care of the source code management. So then when you build, you also think about building not only software, but infrastructure. So we use tools like HashiCorp, Terraform. I mean, in our course, of course, we are talking only about Terraform. So we use Terraform to create infrastructure, and then we can actually deploy our software, right? Then for configuration management, you have Ansible. In this course, I would not like to spend a lot of time on it. Uh, because Ansible has become sort of outdated because Kubernetes is everywhere, but I might just take a session or two on Ansible. And GitHub Actions. Oh, sorry, coming to CI/CD, earlier we used to teach Azure DevOps, but it's also kind of in a sunset phase. Again, you might be confused what is Azure and what is Azure DevOps. I'll come to it in a minute, but we might most likely use GitHub Actions, right? Um, and of course, when we talk about monitoring and alerting, we can't build this very production grade system, but we can focus on Azure Monitor, which is available already. What's happening? It's supposed to go forward, right? Okay. Sorry about it. Once again. Okay, then when we talk about source code management, we also use tools like Git and GitHub. Both are different again. Okay, that's very important distinction we need to make. So we talk about both these tools. So in short, we are going to cover these services like HashiCorp, Terraform. We talk about Ansible a little bit. We talk about Azure DevOps. No, in fact, we talk about GitHub Actions. Azure DevOps is sort of outdated. No one is using that because, Azure and GitHub both belong to Microsoft, right? So everything belongs to Microsoft these days anyway. And of course, the key part of all these things, right, is an operating system. And it's not Windows generally. It's generally a Linux operating. It's generally one or the other flavor of Linux operating system that is used in up all the servers that we are going to configure. So we are going to learn Linux, okay? And then, yeah, we also will learn about, I don't know why Docker has not come up here, but we are going to learn Docker. Okay, Docker, I mean, these days, all the applications are containerized. So Docker is the tool to use. I will also give you a sort of introduction to Kubernetes, very high level. But if you would like to make a career in DevOps role, you have to definitely um, learn more about Kubernetes, implement your homegrown solutions, read about it, and So Docker is the stepping stone to learn Kubernetes. I'll also talk about Kubernetes in our course. Okay, so in short, this is what we're going to discuss. So operating system, we talk about Linux, how does the file system look, how do you navigate? Because when we talk about Linux, it's mostly command line, through commands, you operate your computer. All right. So we're going to use Linux, and also we learn Bash scripting. That's very important. We write automation scripts with Bash. Um, then in the cloud, we talk about account management, we talk about resource groups, identity and access management, virtual networks, virtual machines. In storage, we're going to talk about files, we're going to talk about block storage, we're going to talk about distributed file systems. We talk about DNS and also how to use Azure command line to interact with Azure cloud. So we should try to avoid using the the website as much as possible, the portal as much as possible. We should do it through bash scripting, or we should do it through Terraform, right? If you want to create a resource, yeah, initially you will learn it through the web interface. That's the Azure portal. But as you go along, you have to do everything through a command line or through a Terraform configuration or something like that, right? So infrastructure as code, we will learn how to install Terraform, how to create, how to delete, how to update infrastructure on Azure with Terraform. We might also build some workflows with GitHub Actions on to check how to do it real time, right? Through code completely. Source code management, we use Git and GitHub, like I told you, right? And these two are two different things. Be very careful about it. I mean, very closely related, but not the same. Git is a software. GitHub is a platform. It's a service. It's more than that, right? And software configuration management, Ansible. I just want to take just one session just to give you introduction to Ansible and playbooks and stuff, because Ansible is like very hardly used. I have seen a lot of job interviews of late as well. Ansible is hardly used anywhere. I tell you why also, because back in the day, everything was running on virtual machines. So you have to configure like 10, 15 machines with all the software configuration. Nowadays, you use Kubernetes, or even in some cases, you can manage that with Terraform. So Ansible is not used as much as it was used, let's say 7 years ago or 5 years ago. And continuous integration and continuous delivery, like I said, the automation. I mean, you can think about this in the old school, it's always people talking about Jenkins, right? You have to learn Jenkins. But now Jenkins has become very old. No one is using it. Even people are not using Azure DevOps. GitHub Actions is what people are using. I've seen in like many organizations, right? In many job adverts as well, job description as well, people are asking GitHub Actions because that's much easier. It's integrated uh, within your GitHub, and you need not have to use another tool like Jenkins or Azure DevOps. I mean, it's like storing your code one place and writing your automation elsewhere, but GitHub Actions solves that problem. You can all have it in the same repository. Okay, and coming to containers. What's a container? If you don't know, don't worry about it. It's like a mini virtual machine. We're going to learn about it later. So we'll talk about Docker, how to install it, how to configure, how to build automatically Docker images, and what is an image, what is image registry, and I put Kubernetes in small letters because it's going to be a very 101 session, if you will, very high level, but it's very important, right? If you would like to uh, become a DevOps engineer, even after becoming a DevOps engineer, you need to learn Kubernetes. That's become a de facto implementation for applications these days. And monitoring and alerting, I'll talk about Azure Monitor, how you can configure the metrics, how you can see the logs, and how you can troubleshoot them. Okay, so that's the curriculum as a whole. There might be some difference between what was given to you and, for example, they mentioned about Azure DevOps. Azure DevOps is not the same as Azure platform. It's a separate tool. But like I said, people have started using GitHub Actions instead of Azure DevOps. But maybe we can talk about it. When we talk about GitHub Actions, I can also show how Azure DevOps looks like. Um, and what are the features, but we are going to focus on GitHub Actions. That's what everyone is asking these days. Okay. And remember, our course is DevOps plus Azure. We're covering DevOps technologies plus Azure. It's not Azure DevOps. Azure DevOps is a separate tool altogether. That's how Microsoft confuses everyone. But anyway, Azure is the public cloud, and DevOps is, like I said, it's a set of practices. It's in practice, it's a set of tools that we use. Some of the tools I've mentioned here, right? So yeah, again, so that's what is covered again. I think I'll share this presentation with you as well later. So if you want to go through it, you can go through it. So typically, what are the prerequisites? People ask me generally, like, what do I need to have? Of course, you would need to have a computer. Don't attend the classes on an iPad or let's say iPhone. Try to log in with your computer. Okay, and you also need your own system administrator rights. Preferably, if it's a work computer, avoid using it. Use your personal computer. It could be a very basic computer with 4 gig and i3 or whatever. Because you need administrator rights, because you need to install some tools, like for example, Windows subsystem for Linux. Okay, I'll talk about it later in our course. So if you have to learn Linux, you can learn it from within your Windows system. If you have a Mac or a Linux system, even better. But otherwise, you can learn it from your own Windows system. You just need to install WSL. Okay. and you install a couple of softwares like VS Code, Azure CLI, Docker CLI, maybe GitHub CLI. So these are all CLI tools. That's easy. Of course, you would need an Azure free tier subscription. Otherwise, where will you learn, right? So unfortunately, Azure subscription is only for 1 month. Uh, so you might as well need a backup Azure subscription. That means after 1 month, you either have to move to pay as you go. I think that's the easier method. Like, instead of asking your friend or your cousin or someone to create accounts for you, you can simply spend, maybe if you use it wisely, you will have a bill of 500 rupees or 1,000 rupees. Okay. If you're in India. So you can easily manage that. So a backup subscription is not required, but you will need a free tier subscription. I'll tell you how to create it. Okay. You can already Google it, but don't create it yet because once our course starts, because it's only for 1 month. So not waste it already. So you would also need some other services, but these are all mostly free. You just need to create free accounts on GitHub, Azure DevOps, Docker Hub. If you want to learn about DNS, maybe you can use a service called as Freenom, and you can create your own test domain to test your DNS. Okay. Again, if you don't know what DNS is, that's fine. We are going to learn about it. Personally, very important, you should have the appetite for learning. You should spend for quality time for classes and practice. Like I said, it's very easy to, you know, connect to Zoom and, lie down on your couch and just listen to it passively while something else is going on your television. But I would say, you know, make time for this, sit on a chair and a desk, and preferably follow everything on a laptop or a desktop, whatever you have. Ideally, I would say no prerequisites for the skills because we are trying to cover from the ground up. But if you already have programming or if you are very good with Linux, that's a great add-on. If you And also another thing, it's sort of a disclaimer, and also from my learnings through various classes I have taught, various training sessions I have taken. It's always 50-50. Like, this course is just like the launching pad. You have to work yourselves. You have to practice every day. You have to learn every day. For example, I cannot teach you everything about IP addressing, for instance, right? You have to learn that. Otherwise, our course can go for 2 years. It's like a computer science bachelor's degree. I can go on teaching you every day. Instead, you have to pick up stuff on your own. You have to learn it, and come back and say, okay, I know this stuff. If you have any questions, you can definitely ask me. I will cover the introduction. I will tell you what to learn, where to learn, but you have to learn and practice. Similarly, Linux operating system. It's very vast. I cannot spend like 1 week just talking about Linux operating system. So I'll give you the basics, the overview. I can also give you some resources to practice, but you are the one who should practice every day. Uh, and if you have any questions, you can come back. So it's always very, 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 very important to keep practicing. Maybe the tasks I give, or even you can go beyond that. You can look through YouTube and learn some new stuff, because there's a lot to cover in our course. Honestly speaking, 2 months is never enough, but it can be. I mean, we can make the use of 2 months only if you spend an additional 2 hours every day uh, practicing these tools, learning something out of your own interest. You have to do that, right? Even today, I mean, it's never easy. What's happening around the world of software development these days. AI has disrupted it mainly, right? Everyone is supposed to use AI, they like it or not. And also software development itself has changed a lot. Everyone need to know, uh, understand the concepts of programming, even though they don't implement it. So just don't think that you're going to learn a few tools and you're going to learn few operations of cloud and you're good to go for jobs. No, you have to continuously learn, continuously practice, right? And also, I don't know what's the background for each of you. Maybe we can talk about that later in our courses. Uh, but no matter from which background you're coming, you need to, of course, there are no honestly, there are no jobs for freshers as DevOps engineer. Very rare. Very rare people ask for 0 to 2 years of experience in DevOps. It's mostly 3+ or 4+. So you also have to act like the person who has 3+ years of experience or 4+years of experience. How does that come when you really don't have the real world experience? It's practice, right? You have to practice. You have to listen to some YouTube channels. You have to go through some posts on LinkedIn or wherever you can get them, Reddit, understand how it works in real world, and you have to make it in the interview. So very, very, very important thing. It's like I'm a gym trainer. My part is only like 20%. Rest everything is done by you. You have to practice. You have to learn and implement. I'll give you the complete path of what you have to learn, what it's like in a DevOps engineer's day, but you have to learn and practice every day. That's very, very important. All right. So again, it's mostly, I mean, this course is for both freshers as well as those already working in IT. For example, you might be someone working as a DBA or a quality analyst or even software developer. You will still benefit from it. Or even if you're a fresher, you'll benefit from it because it covers a lot of other software development concepts as well. So we talk about a lot of processes and technologies. Like I said, already mentioned those technologies we are covering. So I aim to give you the right amount of theory plus practice, but mostly on the practical side. We're going to do a lot of practice sessions. We're going to do, I mean, I'm not going to go through PowerPoint every day. I just open my console and start typing commands and explain what's happening. Okay, that's how this is going to be. Not PowerPoints, but mostly doing stuff. Okay. Yeah, there's a lot for you to upskill. But again, like I said, it's always your enthusiasm that counts, your passion to learn and implement solutions, right? The good thing about today's um, ecosystem is you can pick up any technology you and you can start learning it, right? It's not like we are in 2000s, early 2000s, or even up to 2010. If you have to learn something, you have to go to a computer course, computer institute, and use their labs to learn stuff, right? You don't have to do that. You can simply sit at your home, create all these cloud services we talked about. It could be Azure, it could be GitHub, right? It could be Docker Hub, and there's a lot of documentation around. So you can continuously learn, implement, and you can excel. So it's all about your enthusiasm. That's the key part. Okay. So this course itself is not enough, folks, to make you a DevOps engineer suddenly. You have to invest your time. You have to also maybe write a couple of certifications of this course. You can pick up something very simple like mm, Azure DevOps certification or Azure Administrator Associate or something of that sort, and you can, improve yourself. All right. So that's the end of my TED talk. Over to you for any questions.
So, how long is this training on a daily basis? Is it a 1 hour training or 1.5 hours or
No,
2
this
more?
is going to be 1 hour, but be prepared for 1 hour, 15 minutes. Maybe
Okay.
there will be some spillover. Right.
Hmm.
I mean, yeah, career IT folks will talk to you about the time exactly, but I think it's going to be 7 a.m. to 8 a.m. IST.
Okay.
And also, wherever possible, I give you some sort of notes. I'm trying to concentrate everything in a single repository and share it with you. I'll share it with you shortly. I mean, not shortly, as we go along the course. Okay. All right. If you do not have any questions, and thank you so much for joining on a Saturday morning or a Friday evening, based on where you are. Thank you so much, and hoping to see you all in the course. I'm still here for the next couple of minutes. If you have questions, please shoot. Thank you.
How far is this DevOps used in Oracle Cloud? Because every time I listen to folks, I see this is with DevOps with Azure or DevOps with AWS, and nobody talks about DevOps with Oracle Cloud. How does it work?
That's a good question, but here's how things work. DevOps is not related to your cloud provider, right? For example, in my current employer, in my current organization, we use multiple clouds, but primarily our infrastructure, the database, and the compute engine, the Kubernetes cluster, are on Oracle Cloud, right? But we have set up the DevOps practices around all our tooling, including GitHub Actions, everything. So it's about, so the DevOps thing is not related to your cloud technically, you know. Uh, it doesn't matter which cloud you're using, you can still follow. Even you don't have to use cloud. You might have an on-premise environment. You can still follow DevOps practices. So it's up to the organization. So it's the same practices again, right? So if you have Oracle Cloud, they also have a Terraform provider. So you can spin up everything by writing code instead of manually doing it, right? There are two ways. You can either manually do stuff or you can create it through code. You can set up automation for your CI/CD, right? So again, Kubernetes is like very common these days. It has become like an operating system of itself, uh, of its own. So we still use Kubernetes on Oracle Cloud rather than on Azure. We are using on Kubernetes Cloud. It's the same thing, right? Do you still have systems in place to, deploy your code directly into Kubernetes instead of AKS, which is Azure Kubernetes Services, you're deploying into OKE, Oracle Kubernetes Engine, right? It could be as well Google Cloud. So you follow similarly the same practices, or it could be even DigitalOcean. You still follow the same practices, right? So DevOps is about how it is implemented in an organization. It doesn't matter which cloud you're using. It could be Oracle Cloud. Like I said, we have like 4 clouds: Azure, primarily for identity and access management to give everyone access to tools. We have Cloudflare, we implement our DNS, we implement our front end part, we implement our, let's say, um, some security services through Cloudflare. We have some other services as well, right? And then we have Azure. I talked about Azure, but we also use Azure largely for the OpenAI services. Then we use AWS for a couple of services, right? Very small services, but we still use AWS. So for all these things, what we focus to do is create automation through Terraform. We have CI/CD implemented for our main code, right? We follow the secure practices, making sure no secrets are leaked anywhere. So that's how you implement DevOps. So it's how your organization implements rather than not on which cloud you're using. So cloud is literally immaterial to the DevOps implementation. Hope that answers.
Yep, that helps. Thank you.
All right, folks, if you don't have any other questions, thank you so much again, and sorry for the initial hiccups. Wishing you all a very happy weekend and hopefully see you all soon. Thank you. Have a good day.
Have a good one, guys. Bye. Thanks, Kiran.
Thank you.